Peter, welcome. Thanks for being here with us today. Um, Really honoured to have you here, Peter, with us. I think it's fair to say you are quite a trailblazing figure in the world of artificial intelligence, and I understand you actually helped coin the term artificial general intelligence back in 2002, or AGI as it's known now,
Mm.
alongside some other thought leaders. So very inspirational to be chatting with you today. Um, you are now the CEO and chief scientist for IGO AI, and as I understand it, you're building the next generation of AI-based chatbots and agents using more cognitive AI approach rather than the statistical and generative AI based techniques, which maybe we've all become a little bit more familiar with in recent times. So really intrigued to hear a little bit more about your approach to the platform that you're building today, and yeah, just hear a little bit more about you in general, and some of the value you have to share. So if you'd be so kind, it would be lovely just to hear a little bit more about your background. If you kind of give us a whistle stop tour of your career to date, and I suppose what initially drew you to the field of AI in the first place.
Yes, sure. Thank you. So I started out my career as in the electronics field as an electronics engineer. Then I started my own electronics company. But in doing that, I fell in love with the programming aspect of it, programming microprocessors and so on. And my company very quickly turned into a software company. So I taught myself programming, all the different kind of languages in business, and I ended up building a quite successful commercial company with essentially an ERP system for small to medium-sized businesses, covering all aspects of their business. And that company went from the garage to 400 people, and we did an IPO. So that was really exciting.
Wow.
So that was really my start in getting into software was through hardware. And so when I sold my shares in the company, I had enough time on my hands to say, well, what big project do I really want to tackle next? And what struck me is that software really is quite dumb. And I say that I was very proud of the software we designed, but still, if the programmer didn't think of something, it would just give you an error message or crash or do something unintelligent. So that is really the part that drove me is how can we build software that has intelligence, that can actually understand what's going on, that can have common sense, that can reason, and that can learn. And that sort of tied back to, even thoughts I had much earlier in my life in sort of coming across building thinking machines, robots or machines that can think. I mean, obviously, we all came across it in our youth and sort of, yes, that sounds like a really interesting project. And then as I investigated more, I also, came really understood the benefits that we can get, humanity can get from having really smart AI. So that took me on this journey of more than 25 years now, to actually build thinking machines.
Wow, fantastic. Thank you very much for that. And it's a very I think a very emotionally loaded topic at the moment, thinking about this sort of term of AGI. Tend to find that two people sort of sit in two camps at the minute. Some that are kind of see it as like you say, a way to make humanity flourish, in your words, but
Mhm.
others that kind of still potentially perceive it as a bit of a threat, whether that's from an ethics point of view, or from a displacement of human skill point of view. But I think it'd be quite good to sort of draw upon the point you made there about software being done in many contexts, to actually sort of fast forward to what actually is AGI in your opinion. How does it sort of differ from the kind of the narrow AGIs, or the narrow AI that we're
Mhm.
seeing in the world today?
Yes, I mean, there's quite a bit of complexity there. And when I started my journey, I actually took off 5 years to study all different aspects of intelligence as really a foundation. I felt that I had to understand intelligence well to be able to build an intelligent machine. So I studied epistemology, theory of knowledge. How do we know anything? how can we be certain of things? So even that, those topics and related topics in philosophy of ethics and how do we know good from bad. But then also child development. How do children learn? What do IQ tests measure? How does our intelligence differ from animal intelligence? And basically, and understanding all the work that had been done in the field of AI. And the combination of that, I realized that when the term AI was coined 69 years ago, it was really about building thinking machines that can think, learn, and reason the way humans do. That was the original goal.
Yeah.
And in fact, at the time, they thought they could crack this in a year or two. Well, of course, it turned out to be much, much, much harder. So what happened to the field of AI? It turned into a field of narrow AI. But there's something really important that most people don't realize. Narrow AI basically means you pick one particular problem that seems to require intelligence to solve, or does require intelligence to solve. And then you figure out how to write programs, how to use computers to solve that problem, that one problem. So a perfect example here would be Deep Blue, IBM's world chess champion.
Yeah.
How can we play a good game of chess? And the issue here is by pursuing narrow AI, it's the external intelligence, it's the intelligence of the programmer, of the data scientist who's actually solving the problem. How can we build something that's good at playing chess? And it's not actually that you're building an intelligence that figures out how to play chess and that can do things. I mean, a chess computer can't even play checkers. It can't teach itself to play checkers. So the field of AI really, up to now, has been pretty much the field of narrow AI. So when I was ready after my studies to actually start building these systems, this realization, I said, well, we need to go back to the original dream, the original mission of AI. But the term had been so abused by now, or, in everybody's mind, well, narrow AI, if you're solving a particular problem, that's AI. So I actually came across a few other people who had similar ideas, that we felt the time was ripe for us to go back to the original challenge of AI. And we decided to write a book on the topic on how to go about that. And in thinking about the title for the book, three of us, Ben Goertzel, Shane Legg, and myself, decided on artificial general intelligence. And I particularly like that because the general is also like little g in psychology, which is, the parameter for general intelligence. So that's how we came up with AGI in 2002. And now the sad story is that the term AGI is now being badly abused. That people are using the term to say, well, if it can do most things that humans are good at, then we'll call it AGI. And we have ridiculous statements from Sam Altman and other people. Sam Altman recently said that, oh, we'll have AGI soon, but it's not going to be a big deal. It's not going to have a big impact on humanity. So it's absurd to call that AGI if it's not going to have a big impact on humanity, to have a machine that can think, learn, and reason the way a smart human can. Yeah. So I've started using the term real AGI now recently, which is sort of pathetic, that we have to go there.
Yeah, absolutely. Well, that's fascinating, and I really like your approach there, where you talk about actually going back to the roots of what is knowledge and how is knowledge acquired and how it's gained. And for me, obviously you're far more of an expert in this field than I, but the one area that I feel is the beauty of the human brain is that it is an organic organism, and we obviously learn through external stimulus and reacting to that external stimulus, and there's a biological effect that takes place. And I studied biopsychology at university, and one of the things I found most interesting was the actual art of learning of what takes place at a cellular level in your brain. Obviously you have when you're forming new memories, you have a rapid firing at the synapse, and it sort of what's called long-term potentiation, and actually changes the
Right.
interface of the cell between the two. And I always remember thinking that's such an incredible thing. Your brain is such a plastic entity that it can be changed and forged based off exposure to different external stimulus, and that's kind of how we learn context, I suppose, you know, in a very physical way. And obviously it's no mean feat to replicate that in a digital, you know, kind of binary world of ones and zeros. You know, it's such an incredible feat to even take on that. But talk us through a little bit about some of the work you're doing at AGI, and how the platforms you're building are sort of using more of this cognitive AI based approach, you know, versus some of the more kind of the generative AI and LLM stuff that we're seeing out there at the moment.
Yeah, you know, you put your finger on a really important point, and that is the intelligence that we have is very much interactive. It's adaptive, you know, in real time. As you say, it uses a context, and it's really the crucial thing about intelligence is the ability to learn new things and to integrate them, to be able to generalize. You know, what you learn, you integrate and say, well, this is similar to something else I know, or this is different, you know, so that this whole dynamic process of learning is really critical in human intelligence, and therefore in AGI. Now, what we have right now, though, is the focus is almost 100% on statistical systems. They don't learn interactively at all. You know, you have 10 trillion bits of information dumped from the internet that are number crunched over weeks of number crunching, you know, at $100 million worth of number crunching. And you then have the static model that's been built. So the focus there is on having a lot of knowledge and skills rather than on being able to acquire knowledge and skills interactively. These current models cannot learn, they cannot change anything during operation. They cannot, you know, they don't update the model. It's a read-only model. So that's kind of one of the big problems that with the current approach is it misses this crucial element of intelligence, of being able to learn interactively. I mean, there are other issues as well with the data they've trained on. You know, 10 trillion bits of information or more is good, bad, and ugly. You know, it's a mixed bag. And of course, when they generate a response, the model struggles to know what is good and bad and ugly. You know,
Yeah.
And that's why we you know have this problem of reliability of confabulation or hallucinations,
Yes.
and so on.
Yeah.
DARPA actually have an interesting presentation that they gave a few years ago, and they talk about the 3 waves of AI. And what they mean by that is the first wave is now most people call it good old-fashioned AI. So that's the stuff that was done in the 70s, 80s, 90s. You know, again, a Deep Blue would be a good example of that, expert systems and so on. So those are kind of logic-based systems, the first wave. And then the second wave, you know, hit us like a tsunami about 10, 12 years ago, when people figured out how they could use massive amounts of data and massive amounts of computing power to do really useful things. And I mean, they're doing astonishing things with, you know, if you look at ChatGPT and other large language models, it is truly amazing of what you can do with just huge statistical models.
Yeah.
But that's the second wave, which is really focused on statistics and big data. And what DARPA mean by the third wave is really much closer to the way I think about AI or AGI. Your starting point has to be understanding intelligence. You want to build a system where the important aspect is that it can learn. You know, it can learn interactively and integrate new knowledge and reason about it and know what it's learning, to have a deep understanding. So that's the third wave. And you know, until the momentum shifts over to this cognitive AI, to the third wave, you know, we are not going to get to AGI with purely brute force statistical approaches.
Yes. Yeah. It makes total sense. You really kind of clarified for something for me there, and kind of hit the nail on the head, I think, in terms of yeah, even though a lot of the statistical and generative AI approaches that we have today are, you know, being trained on unfathomable volumes of data, which are obviously incredibly powerful. When you say you set it to a particular task, it does still. I think back to my GCSE IT when you're thinking about a traditional software system, and it's garbage in, garbage out, right? And obviously it's very finite in terms of actually what it can achieve based on what it is being trained on. And like you say, the ability to form an intelligence which is far more integrated and able to do that reasoning piece, clearly has to be the missing link here in terms of when we're talking about AGI. But interested to understand from your point of view, Peter, how far do you think we've actually come in the pursuit of AGI, and what do you think have been some of the kind of more notable milestones or breakthroughs so far?
Yes, so we started in earnest in 2001. After the research that I did, I had an architecture and idea on how to build this, and I hired a team of about 10 people, and we worked for about 5 years on building basic prototypes and really testing out the ideas that I had on how to build this with concept formation. And so some of the breakthroughs were really understanding how important concepts are in human intelligence, and being able to build a system that can learn via concepts, that can conceptualize and generalize, and to do that effectively. So we came up with a knowledge graph approach that encodes all of the knowledge and skills that the system learns in a super effective way. So our approach, the knowledge graph that we came up with, is actually literally 1,000 times faster than any commercially available graph database. So that was kind of one of the key breakthroughs in figuring out how to build a very efficient system, and how to do that. Now, after about 5 years or so of building the basic framework and tools and so on, we had something that actually was already quite viable commercially. So the company then focused on commercializing this technology. We also needed to make money. There was only so much money I had from my previous company. So we basically commercialized this in the call center space, in automating call center calls. And then for several years it was really focusing on building data centers and making it industrial strengths, bulletproof in terms of reliability and security and redundancy and building a commercial company. So I sold that company eventually, and then went back to again focusing on the core AGI engine to basically make it smarter, to take it to the next level. And this is what our current company now does. We again have commercialized it in the call center space. And in fact, a few weeks ago, we had Valentine's Day here, and one of our big customers is 1-800-Flowers and Harry and David group of companies. And we actually replaced 3,000 agents. There's obviously this massive spike in Valentine's Day and just around there for customer service. So that's sort of the commercial application that we have now, is as a conversational AI that has memory, that has short-term memory. It remembers what you said earlier in the conversation. It remembers what you said in previous conversations. It can reason about the situation. So, if you say that I want to buy some chocolates for my niece for her birthday, then the system will remember that, and next time around it can potentially use that in a conversation. So that's very powerful from a commercial point of view to be able to do that. But we really need to continue working on cranking up the IQ of the system. So a few months ago I restarted a concerted effort again at the moment we have a little more than 10 people working on that, to again focus on cranking up the IQ. And this time we believe we are close enough that we can actually get to human level intelligence with this effort within a few years. We already have so much experience in how to build these learning mechanisms and reasoning mechanisms and so on. But whenever you commercialize something, then your focus is, of course, on what are the short-term commercial requirements. I call that the narrow AI trap. If you're trying to develop AGI, as soon as you try to beat benchmarks or you try to get a product out the door quickly, you end up again having this external intelligence. You basically just hard code things and so on. You're not that concerned about how fluid the intelligence is. You just wanted to be able to do, the task. So that is a challenge for anybody working on AGI, and we that's something we've had to manage over the years. And as I say, we now have a very solid project that we are busy expanding and trying to expand to really get us to human level AGI.
Wow, fantastic. That's very, very interesting to hear. So, I mean, in terms of, put you on the spot now, but in terms of a number of years, you think from where we are today to when you think we kind of really hit that milestone of achieving that in this sort of context, what do you, how far away do you think we are?
Well, I always answer that question. I don't measure it in terms of years so much as I measure it in terms of dollars.
Oh, a very good point. Yeah.
And the reason for the reason for that is, I mean, the generative AI has just been so incredibly impressive. You've seen a number of companies that have raised. I mean, one company I think raised $600 million in seed funding. I mean, seed funding, $600 million, no product, no customers, just because they were the experts from OpenAI, or wherever. And that kind of money gets thrown at generative AI right now. But it sucked all of the oxygen out of the air, basically. If you talk to VCs or if you want to publish papers or do a PhD, that's really the only game in town. People haven't really come to the point where they've identified this third wave of AI, of cognitive AI. So it's not easy for anybody working in that field to actually get the kind of money that you need. But to answer your question a bit more, I actually feel quite confident that if we could have a team of about 100 people, I actually have a detailed roadmap and plan that we could get to the learning ability of say a smart 10-year-old, and then of course from there on it's just a matter of teaching the system, or the system really learning by itself the different skills that you need, and for to do different tasks. And I believe we can achieve that within 3 years, given the funding to scale up our team.
Oh, you heard it here first. It would be very impressive to see. But yeah, I mean, it kind of brings it into context the point you were making at the beginning about when artificial intelligence was coined 69 years ago. It was to genuinely replicate the human mind and our way of thinking. And why do you think there has been? I mean, obviously we've seen massive success stories like OpenAI with ChatGPT and that kind of thing, where people are interacting with this thing and it appears to have this unbelievable level of intelligence. But as you say, once you kind of dig under the surface a little bit more and you do understand the difference between what you're describing here as cognitive AI versus generative AI, to me it feels like it's a much more exciting and interesting field to pursue the actual pursuit of creating something that is akin to genuine intelligence, other than the commercial viability, like I say, of getting a product out and it making money. Why do you think there has been this sort of reticence to follow more of the cognitive AI based approach?
Well, one thing I've noticed is I've also been involved in investing over the years, and since the dot-com boom, the investing scene has shifted very, very much into momentum investing. People put money into whatever goes north, and hopefully cash in their chips before it starts going south. And so it's not, VC investment is really what's hot at the moment, and that feeds on itself. And statistical AI, of course, has achieved a lot. So it's not just hot air,
Of course.
But that's really where all the money is going. But there is something more subtle, that because statistical AI has been so successful for more than 10 years now, with the original, image recognition and speech recognition with deep learning, with DeepMind, and progress that was made there, we have actually a whole generation of computer scientists that don't know any other AI. their background, sort of self-selecting, their background is basically statistics, mathematics, logic.
Mm.
It's not cognitive psychology or
Yeah.
cognitive science.
Mm.
So people really don't feel comfortable. It's actually pretty rare to find a researcher who's very comfortable thinking about the problem from a cognitive psychology point of view to understand how cognition works. Concept formation, metacognition, where emotions fit in. The whole how does the mind work? And I think you really need to understand that as a starting point if you're trying to solve the problem of building intelligence. You really have to have a good feel for how the mind works and how intelligence works. But
Yeah.
then at the same time, you also have to have the technical understanding on how to actually instantiate that in a modern computer. So that overlap is quite rare. So the problem is that people really don't understand cognitive AI, and there isn't momentum on it yet. We're trying very hard to build that momentum.
Mm.
So it's kind of an accident of history that statistical AI has been so successful, and it sort of just that's the only game in town,
Mm.
essentially.
Yes,
Um,
yes, yeah. It's a very good point, and I guess it's sort of like I said, becomes almost exponential, doesn't it? When it's taken over in the way it has, and then like I say, people follow the money, people follow the skill
yeah,
sets, and it becomes very
right.
difficult to
But
review.
I see that changing because if you get past the sales hype, marketing hype, if you go past the hype of people trying to raise money in generative AI, where they might still make statements like, "Oh, we can get to AGI, just give us more money." The famous paper that started the GTP and large language model thing was. Attention is all you need. That was sort of a technical paper that introduced transformer architecture, which is really the key breakthrough to make large language models work well. So it was attention is all you need, and now you have Sam Altman saying is $7 trillion is all you need. That we need to scale up, we need to build chip factories, we need to build nuclear power plants to power these things. And it's kind of absurd. Our brain works on something like 20 watts, and here you're talking about building AGI with gigawatts, requirements of gigawatts. Whereas the cognitive AI approach, because it learns incrementally in the way it works, doesn't have these massive training requirements or power requirements.
Yeah.
So the point I want to make here is that if you get past the sort of sales hype and the money raising hype of where generative AI will take us, if you talk to the actual scientists, they say large language models will not get us to AGI. They actually understand that. They say we need something more.
Mm.
But from their perspective, they don't actually know what that more is. They just know large language models are not going to get us to AGI by itself.
Yeah.
Now, from my perspective, I can see, yes, of course, they won't get you there because they don't inherently incorporate the requirements of intelligence, to be able to learn interactively, incrementally, and not have this brute force training backpropagation training system. So, eventually people will, they already realize that we need something else. We need new ideas to get to AGI. And hopefully more people will realize that cognitive AI approach is actually the way to go.
Yes, yes, I can believe it. Absolutely. I mean, just from speaking to you now, it's been very eye-opening for me, absolutely, in terms of kind of my understanding of that particular market. And I work in it all day, every day as part of my job, right? So, but really interested to pick your brains a little bit on the yeah, excuse the pun, on the when you talk about cognitive AI and how it's approaching things from understanding the cognition element. When you were building IGO AI, you said you sort of adopted more of a knowledge graph approach. how much of the approach, bearing in mind you've been trying to replicate a organic kind of beautiful organic machine in a brain, how much of it has been focused on understanding the biology of the brain and trying to replicate that in digital form, insofar as the way the brain is conducted as a whole, but then the parts within it, and like you say, where emotion is implicit within communication and that kind of thing. How much of of that has informed your work with Igo AI, and sort of how much have you relied on the biology of the brain before sort of thinking about the next abstract layer up of cognition?
Yes, absolutely. I did spend quite a bit of time trying to understand how the brain works and how other, early AI research, in the 70s and 80s and 90s, um, did actually try, there were quite a lot of work done in trying to replicate the way the brain actually learns, in a obviously still more abstract way. And there are definitely lessons to be learned from that in terms of Hebbian learning, association learning, and as you mentioned as well that you have like priming, that you're primed for certain ideas. So the feedback loops in the brain, for example, in vision, they're massive feedback loops that anticipate the kind of thing you're trying to recognize. So I think there's quite a bit in sort of the brain architecture, neural architecture that is useful for coming up with ideas. But one shouldn't take that too far because we're really not trying to reverse engineer the brain. We are trying to, if anything, reverse engineer the mind. And there's a really good analogy in terms of flight. We've had flying machines for over 100 years now. We still nowhere near reverse engineering a bird. So you don't want to say, well, we can't possibly have a flying machine because it doesn't have as many cells as a bird has, or as many neurons as a bird has, or as many feathers, So it's so I think getting inspiration from the way the brain works absolutely is useful. But really, the correct model is how the mind works, and trying to build an artificial mind.
Yeah, that's really interesting. I love that analogy. I'll steal that one if you don't mind. And
Mm.
no, definitely, it makes a lot of
Mm.
sense. I suppose we wouldn't be able to talk about AI in the world that we live in today without talking about the sort of possible ethical ramifications of being used as, of course we're talking here as a context for a force for good, but we get to that point where unfortunately any intelligence or tool of power could also
Yes.
be used for a negative concept. So how do you feel that we can mitigate that risk and ensure that once we get to the point that you mentioned, which could only be 3 years away in this particular situation, it's developed and utilized responsibly?
Yes, it's a very, very complex topic in terms of AI risk, and I'll talk about how I believe cognitive AI is inherently much less of a risk than the current AI we have in a sort of a more mundane way. I'll talk about that in a bit, but I do want to just mention that we're in a very unfortunate situation that people get their knowledge about AI from Hollywood blockbusters that the AI is always a bad guy and destroying the world or taking over. So that's sort of our default understanding of it. And then building on that, we've had an extremely well-funded movement for the last 15, 20 years of what some people called AI doomers, but basically people who say AI is going to kill us all and it's a huge risk. And for whatever reasons, a lot of money has flown into that, and there are literally hundreds of millions of dollars going into these organizations that employ hundreds of people, very smart people, who write about the risks of AI. But almost all of them write from a purely theoretical point of view. They make certain assumptions and then run with those assumptions. Hardly anybody there actually works on building AGI. So they have this very abstract misunderstanding.
Yeah.
And the problem is, you can raise money when you say the world's going to end unless you listen to us and pay us to do research. Whereas on the other side, the counter arguments, there are virtually no organizations, there's virtually no funding for people who have a full-time job to say, no, what these people are talking about actually doesn't make sense. So, I'm the bottom line here is I believe a lot of the papers that are published and the reasoning that's given for why AI is so dangerous, as an existential risk. I'm talking at that level.
Yeah.
They're just flawed. And I'll give just one simple example here. The original example that was given that sort of is often quoted is basically a paper clipper. So the idea here is you ask your AI to make you paper clips, for whatever reason, that's the business you're in or whatever, and says, make me paper clips. And the system has that as its goal. And it basically now focuses, it optimizes that goal and turns the whole world into paper clips. Now, even listening to it now, it sounds like such an absurd argument, but once you put it into sort of an academic sounding setting and so on, it was plausible enough for a lot of smart people to fall for that and to actually fund this research and say, yeah, oh, wow, yeah, this would be really bad if we had an AI turn us all into paper clips, But I mean, you just stand back and just use common sense and say, so on the one hand, you're saying there's a system that's smart enough to outsmart us all to prevent, stopping it from paving over everything with paper clips. It's smart enough to outfox us all, but it's not smart enough to realize, well, you didn't actually want, you wanted a limit number of, there was a reason you wanted paper clips, you wanted to corner the market for paper clips or whatever. Yeah. So there are these really fundamental errors of logic in the approach. But then there clearly is what I would call sort of the mundane risk, not existential risk, but mundane risk. And by that mundane, I don't mean to say they trivial or we can ignore them. And statistical models are actually quite prone to that because they don't know what they're doing, because they do hallucinate. So they can make errors, and these errors can have bad consequences. I mean, one of the funnier ones is that a Chevrolet dealer, used a chatbot based on LLMs, and a user said, "Will you sell me this new truck for $1?" And the chatbot said, "Yes, sure." And then the person followed up and said, "Are you sure this is legally binding?" And the chatbot, "Yes, it is." I mean, that's kind of funny, and that you can laugh about it, but those kind of errors, because these large language models don't know what they're doing, and of course, faking people, faking videos, and so on, clearly, it does have negative consequences. But that brings me sort of to the other side of saying why I believe a cognitive AI inherently doesn't suffer a lot of these kind of risks, is because it knows what it's doing. It has intelligence. So a lot of the problems with current AI that we are facing are because they're not smart enough. They don't know what they're doing. It's like having a bull in a china shop. It's basically, they have all this power, but they don't really have this deep real world understanding and the mistakes they make or how they can be abused. Whereas with cognitive AI, it will know what it's doing. It'll be smart.
Yes, absolutely. It's it's really interesting to hear you talk there, because it almost feels like in many ways, like you say, people get fed information. Everybody builds their belief system, I guess, by the stimulus they're surrounded by on an external basis. And like you say, at the moment, there's, I think, a lot of false information out there. But when so many people believe in something, at what point does it become the reality? And it almost becomes a very philosophical argument around, what is truth? What is there truth? Is it true if enough people believe it, or actually is there a
right? It's important to understand that. But I really do want to talk about the positive side of AGI. And normally, I mean, there's a good way of thinking about this. Imagine having a PhD level cancer researcher, an AGI that taught itself or was taught to become a PhD level cancer researcher. You can now make 1 million copies of that AI. And you now have 1 million PhD level cancer researchers chipping away at the problem. We're obviously going to make much more rapid progress. you take that same idea and apply it to any scientific endeavor, whether it's more efficient batteries or, pollution, or even governance. We don't seem to be very good at that. You can apply this intelligence, but you can, multiply it sort of almost infinitely, to have massive amounts of brain power applied to helping us solve problems.
Yeah.
That's one category. The other category is, of course, that any certainly desk-bound job, leaving aside robotics, we can have a massive reduction in the cost of goods and services. And that's sort of where the idea of radical abundance comes in, where, originally nuclear power was touted as, too cheap to meter. And it could have been, actually, if they continue developing it and improving safety and so on. But we'll see that with AGI, that the cost of goods and services will really dramatically drop. And then the third category that I'm particularly fond of is, imagine that each one of us have a personal assistant. And I call that a personal assistant, for three different meanings of the word personal. The personal, you own it. It serves your agenda, not some mega corporation. Second, personal is hyper-personalized to you. It knows what your history, your dreams, who your friends are, and all of that. And the third, personal, is the issue of privacy, that you decide what it shares with whom. So just, imagine those like three buckets, and that's not the total extent, but how they will improve human flourishing, through research, reducing the cost, and having this hyper-personalized, wise helper, assistant that can help you think things through, make better decisions, and help humans flourish.
Yeah, wow, fantastic. I personally can hugely see the advantage and the benefits in what you're talking about there, and not only from those sort of human progress perspectives, but also, as I understand it, just from our ability to adopt these technologies from a computational standpoint, and actually the work that's involved in it. As I understand it, there's a lot lesser kind of processing power, memory space, energy that's required to adopt this kind of approach. Like I say, the human brain runs off 20 watts versus the unbelievable power that is needed to generate all of these generative AI solutions. So are you able to speak to that as well? Is that something that
yes, absolutely. Many orders of magnitude less time required to train the system, and computational power required. So it is really getting much closer to the brain, the 20 watts, and being able to learn incrementally in real time. Except you can speed it up, and you don't need 20 years to get to a PhD. You can speed that up and get that done in days or weeks.
Yeah, fantastic. Well, Peter, I thoroughly enjoyed this conversation. I think it's been really insightful, and can see why you are such a thought leader in this space. And it feels like we're on a very exciting trajectory, and you're on this sort of precipice of about to break through. And I'll remember this conversation for a long time to come. But I like to end every episode of the podcast by asking the same question, if you would kindly indulge me, and that is, in your your years of experience and your expertise in your domain, is there one piece of advice that you've received throughout the years that resonates with you most, that you would kind of care to pass on to your fellow humankind?
There's probably the one thing that I regret quite a lot in terms of talking about business, and that I only started my own business when I was 25, and I wish I'd done that like 10 years earlier. If you're that way inclined, that you have ideas you want to explore, if you have this sort of entrepreneurial streak and motivation, the sooner you start, the better. Even if you fail, or if you work as an apprentice with somebody, do it part-time or whatever. But the sooner you actually learn to take responsibility for your ideas, and how to deal with customers, with investors, and all of that, the better. So that's one thing that kind of sticks out for me.
Fair enough. Fair enough. Well, starting your own business at 25 is, certainly doing better than most. But no, I definitely take the sentiment on board. So yeah, I guess nothing remains but to say thank you again for spending time with us today. We really enjoyed the conversation, and I will eagerly, yeah, keep an eye on your progress. All the very best. Continuing your success with IGO AI. I'm sure it will go from strength to strength. But please do come back on and have another chat with us at some point in the future. Would love to hear more about your progress and go from there.
Yeah, absolutely. And thank you. Some good questions, good conversation. And anybody interested in helping make AGI happen, please contact me, Peter at IGO AI. You can find me on LinkedIn and Twitter and so on.
Absolutely. I'm sure we'll put some contact details in there so people will reach out, which I'm sure many people will off the back of listening to this. But no, thanks again for being here, and yeah, look forward to speaking to you soon.
Thank you.